Friends, this is Sridhar Patnaik. Today we are going to learn some more problems on differentiability. X is equal to x into e power 1 by x minus e power minus 1 by x by e power 1 by x plus e power minus 1 by x. For x not equal to 0 is equal to 0. For x is equal to 0. Then f is. This type of questions are giving in JEEMAINS, either true or in that not derivable at x is equal to 0, not continuous at x is equal to 0, but not derivable at x is equal to 0, but derivable at x is equal to 0. Let us examine of x. We shall calculate this. Limit extends to 0. X into e power 1 by x minus e power 1 by x by e power 1 by x plus e power 1 by x. We clearly observe that x into something, this is must be equal to 0, f not, this is equal to. So f is continuous at x is equal to 0. There is no any doubt. Continuous at x is equal to 0. Register not L f dash 0. I want it to be calculate limit extends to 0 minus x into e power 1 by x minus e power minus 1 by x divided by e power 1 by x plus e power minus 1 by x minus 0 by x minus 0. These x will get cancelled here. This is limit extends to 0 minus e power 1 by x minus e power minus 1 by x plus e power 1 by x plus e power minus 1 by equal to 0 minus h. We have to substitute. In this case we get limit extends to 0 e power minus e power 1 by h divided by e power minus 1 by h plus e power 1 by h. Here h tends to 0 e power minus 2 by h minus 1 divided by e power minus 2 by h plus 1. 0 minus 1 by 0 plus 1, this is minus 1. Left hand derivative at x is equal to 0 is minus 1. Now I want to calculate right hand derivative r f dash 0. Similarly this will come like this, e power 1 by x minus e power minus 1 by x divided by e power 1 by x plus e power minus 1 by x. Because x will get cancelled, substituting this, using this, here x will get cancelled. Here also the same way, the same thing will happen. As limit h tends to 0 e power 1 minus e power minus 2 by h 1 plus e power minus 2 by h 1 minus 0 by 1 plus 0, because as it tends to 0 e power minus 2 by h is 0. That's why 1 minus 0 by 1 plus 0 1. Here left value left L is not equal to r f dash. These two are different. Therefore f is not derivable at x is equal to c. Continuous at x is equal to 0 but not derivable at x is the right answer. Right answer. In IIT exam, friends, this type of questions will mapping A 1, 2, 3, 4, 5 questions will given. In this side 6 answers will be given, mapping to problems. What value of m? F is continuous and f is derivable. You see friends, for continuity limit extends to 0, f of x is must be limit extends to 0 x power n sin 1 by x. We all know that minus 1 is less than or equal to sin 1 by x is less than or equal to 1. So that this function is bounded function. This function is bounded function. If it becomes, we want it, if m greater than 0, limit extends to 0, x power m is becomes 0. If m less than 0, this becomes 1 by x, this goes to infinity. That's why if m greater than 0, limit extends to 0, x power m is equal to 0. This is bounded function and this sequence is converges to 0. Therefore, limit extends to 0, x power m sin 1 by x is equal to 0 if m greater than or equal to 0. This equal to f0. Therefore, f is continuous for m greater than 0. F is continuous for m greater than. Okay friends, let us examine the derivability. Extends to 0, f of x minus f0 by x minus 0. This becomes limit extends to 0, x power m sin 1 by x is 0 by x minus 0. This is limit extends to 0, x power m minus 1 sin 1 by x. This is bounded function. This function converges to 0 if m minus 1 is greater than or equal to 0. m minus 1 is greater than or equal to 0 or greater than 0. Therefore, m greater than or equal to 1. This function is continuous if m greater than 0. This function is derivable at x is equal to 0 if m greater than or equal to 1. Okay, friends, is equal to tan inverse 3x minus 2 by 2x plus 3. Then dy by dx is equal to dash. This is the question. Is equal to tan inverse minus 2 by 3 x minus 2 by 3 1 plus 2x by 3 1 plus. This is here I have taken this x minus 2 by 3 1 plus x into 2 by 3. This is of the form tan inverse x minus tan inverse 2 by 3. Now derivative of dy by dx is equal to tan inverse x 1 by 1 plus x square. 1 by 1 square. With respect to tan inverse x by root over 1 minus x square is equal to. Now suppose that this equal to y, this equal to z. My dear friends, we have to calculate dy by dz. In this case, I like to take x is equal to sin theta. This becomes y is equal to sin inverse 2x into root over 1 minus x square sin inverse sin 2 theta. This becomes 2 theta. Therefore, dy by d theta is equal to 2. In this case, z is equal to tan inverse tan theta. This becomes tan theta because sin theta, this is 1 minus x square, tan inverse get cancelled, z is equal to theta, dz by d theta is equal to 1. Therefore, dy by dz is equal to dy by d theta by dz by d theta. This is equal to 2. In EAMCET, there is a chance to ask in